So in this video, I'm going to solve a model problem. It's something related to artificial neural networks. In particular, we are going to solve a perceptron. So perceptron are the building block of the artificial neural network. Your typical artificial neural network can contain one single perceptron, or it can contain multiple perceptrons. It can contain only one layer with one perceptron, or it can contain more than one layer with each layer containing more than one perceptron. This is something that we learned during the lecture hours, but for the moment we are going to solve a single perceptron that contains 4 inputs, and then we have some data. So 80% of the data will be used to train the network. In this case, for training we are not going to use MATLAB. We are going to solve it using pen and paper. And then once we solve the perceptron, we are going to test the accuracy of the perceptron with 20% of the data. So the problem statement or the problem is just solve the perceptron, and the goal, when I mean solve means the perceptron should predict the target T for all the given inputs in the data set. So where is the data set? Data set is here. You have sample number and then 4 input variables x1, x2, x3, x4, and then the corresponding output, which is called T. T refers to the target. And we have 4 samples here, 1, 2, 3, and then 4. So for the first sample, we have 4 measurable quantities, x1, x2, x3, x4. So if the measurable quantity x1 is equal to 1, x2 is equal to 1, x3 is equal to 1, x4 is equal to 1. And if that's the case, then the corresponding output, which is T, that should be equal to 1. And similarly for the last sample, 4, sample number 4, 1, that's x1, x2 is minus 1, x3 is equal to minus 1, x4 is equal to plus 1, and then the corresponding target value, that should be equal to minus 1. So that's the problem. So what we have here, I just summarized the question. So we have 4 variables, x1, x2, x3, x4. So it's a multivariate data. And then you have one output, which is target T. So once we build the perceptron, once we solve the perceptron, we have to test the perceptron for its accuracy for the given input in the data set given below. Yeah. So again, you have 4 inputs, x1, x2, x3, x4, and I gave the values here, minus 1, 1, minus 1, 1, and then the corresponding target is T. So how the perceptron looks like? So this is a typical structure of a perceptron. This is something we studied during the lecture hours. You have some summation box. So you have some summation box, which is here. And then you have a lot of inputs, x1, x2, x3, x4. And summation box also contains something called bias, which is B. And then you have some net output called I. And then the net input will be fed into some box that contains a function f of I. So this is this is a function of I where I is the net input. Yeah. So this is a function, we call it propagation function. So propagation function, and then the rule for the propagation function is if this I value is equal to 1, then if I value is greater than 0, it's going to fire an output of 1. And then if I value is equal to 0, then it's going to fire the output value of 0. And if the net input I value is less than 0, then it's going to fire an output minus 1. So on the output from the propagation function, which itself is a function of I, so we are going to use the symbol O for output. So that's the perceptron. So how the perceptron works. So this is something we learned in the lecture hours, but I will summarize one more time. For this case, we have 4 inputs. So 4 inputs, x1, x2, x3 and x4. That's 4 inputs. This will be fed into a summation box. So this is the structure of the perceptron. Everything begins with the summation box. So what value enter the summation box? So you have x1 and then that will be multiplied with weight called w1. You have x2, second input, that will be multiplied with another weight called w2. x3, third input, that will be multiplied with another weight, let's call w3. And x4, that will be multiplied with another weight, let's call w4. So what happens is your net input will be equal to summation of wi multiplied by xi plus a single bias. So you have a bias as well here. So this bias, I will tell what this means. Bias is something related to your learning rate and then the actual experimental output, the expected output. So this is something related to learning rate and the expected output. So this I values, this makes the net output. So what actually I is, it will take your input, first input, multiply it with weight 1 plus second input, multiply it with weight 2 plus x3, multiply it with w3 plus x4, multiply it with w4, and then finally it will add the bias value. So that makes the I value. So that's called net input. And the common notation for this is I. And this will be sent to a box that contains so-called the propagation function f. F is a function of I. And we set the rule already. If I is equal to, it can be any function, but for the moment we are using a very simple function. It looks like a step function. So that it will fire an output, which is a function of I. It will fire an output 1 if the I value is greater than 0. It will fire an output of 0 if I value is equal to 0. It will fire an value of -1 if I value is less than 0. So f of I is a propagation function here. So what do you mean by solve the perceptron is you have to find the right value for w1, w2, w3, w4 and the bias, so that when it reads your input, it should give an output that should match with your target value. Yeah. So if we go back to the problem, so you have to calculate weight and bias, all the W1, W2, W3, W4, so that when you feed these values as input 1, 1, 1, 1, it should fire an output of 1. Or if you feed these 4 values 1, 1, 1, -1, it should give an output value of -1. So that's, if you manage to find the W1, W2, W3, W4 and bias that can predict your target for the given input, then the perceptron is said to be solved. So that's the rule. So let's solve the perceptron one by one. Obviously, the first step, we have to calculate W1, W2, W3, W4 and WB. And B. B is for bias. And then to solve, we have to assume that initial weights and bias is equal to 0. So which means W1 will be equal to 0, equal to W2, equal to W3, equal to W4, and that's equal to bias. So all equal to 0. So let's draw the perceptron. You have a summation function. So x1 equal to 1, x2 equal to 1, x3 equal to 1, x4 is equal to 1. So what this 1, 1, 1 and 1, so this comes, if if you go back to your problem, so that's your first set of input, 1, 1 and 1. Yeah, so let's begin with the first input. I mean the first data, first sample, and we know the corresponding input that corresponds to the sample number 1. So let's put W1 equal to 0, W2 equal to 0, W3 is equal to 0, and W4 equal to 0. And then let's assume bias is also equal to 0. So let's calculate the net output, net input. So your I value will be equal to 1 multiplied by 0 plus 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 your bias is also 0, so that's equal to 0. And then that goes to your propagation function f of I, and we got the value of 0. So if you remember the propagation function rule, if I is equal to 0, then f of I will be equal to 0. So that fires an output, net output, that's equal to 0. And then if you go back to the problem here, that output doesn't match with your actual target value. Just follow the, so this target should be equal to 1. So this is not matching with, and we know that for the given input the target should be equal to 1. So what does that mean? Which means target is not equal to output, net output. So which means we have to adjust the weight and bias. So that's the rule. So to calculate the weight, you have to calculate the change in weight. So let's calculate the change in weight. W1, delta W2, delta W3, delta W4, and then the new B. Yeah, let's call it B. This will be equal to the new B, bias value. So the formula for change in weight is simple. It's just alpha multiplied by T multiplied by your input. So alpha is a learning rate. Let's assume learning rate is equal to 1. And then T is your actual target value, in this case equal to 1. And then your X is your corresponding input. Yeah. So for delta W1, that will be equal to alpha T into X1, delta W2, alpha T X2, for delta W3, alpha T X3, for delta W4, it should be T alpha multiplied by T multiplied by X4, and then for change in bias is just learning rate multiplied by your target. So what this value? So we know T is equal to 1, alpha is equal to 1, and X1 is equal to 1. So 1 multiplied by 1 multiplied by 1, that's equal to 1. The same for all. 1 multiplied by 1, that's equal to 1. 1 multiplied by 1 multiplied by 1, that's equal to 1. Similarly, this is equal to 1 and this is equal to 1. Bias is equal to 1. So now we need to update the weight and bias. So we have to update the weight and bias until the perceptron read all the inputs and calculate the output that should match with target in all the data set. So which means if you have 4 inputs, in this case we have 4 inputs and 4 samples. So for all the 4 samples, it should read all the inputs and then it should predict the corresponding output. So you have to find a weight and bias that can solve the entire data set. So we need to get 100% accuracy. So it should read all the inputs and then it should predict the corresponding outputs, no matter how many samples you have 4 or 100. So until then you have to update the weights and bias. So how to update the weight? So W is equal to delta W plus old weight, and then bias, new bias will be equal to old bias plus the new calculated bias. Yeah, so That's the rule. So our W1 will be equal to our the change in weight is equal to 1 plus our old bias is equal to 0, that's equal to 1. And same for W2, W3, W4, this is equal to all equal to 1. And similarly bias, the new bias that we calculated is 1 plus the old bias is equal to 0, so that makes 1. And then once you calculate, you update the perceptron with new weights and bias for the next set of inputs. So what do I mean by that? So we have the sample number 2, x1 is x2, x3, x4, and for sample number 2, x1 is -1, x2 is +1, -1, -1, and then the corresponding target is 1. So where this number comes from? If you go back to the question again, so this is the sample 2. So that's the sample 2. So we have some 4 inputs and then the corresponding output value of 1. So that's what we are trying to solve now. So let's go back, draw the summation box. So this is a perceptron again. So now the x1 equal to -1, x2 equal to +1, x3 is equal to -1, and x4 equal to -1. So -1 +1 -1 +1, and then we already calculated the new weights from the previous step. So if you go back here, so just follow the red line. So we have the new weights, weight 1, weight 2, weight 3, weight 4 is 1, new bias is 1. So let's enter these values in the perceptron here. So weight 1 is 1, weight 2 is 1, weight 3 is 1, and weight 4 equal to 1. And the bias, the updated bias, which is also equal to 1. So now you calculate the net input. So the net input will be -1 multiplied by 1 plus, and 1 multiplied by 1 plus 1 multiplied by -1, sorry, no, this is -1 multiplied by +1 think I'm doing correct, plus, so you have two -1 here, -1 +1 -1, and then plus -1 multiplied by 1 plus 1 multiplied by 1. So this, you take all the input and then multiply by the weight, which is 1 1 1 1, and then you sum them and then you add it with the bias, which is 1. So that should give a net input value. This should be equal to -1, and when you pass it to the box that contains a propagation function, it's going to fire an output which is equal to -1. And if you compare it with the target t value, which is here, follow the arrow, so t is equal to 1. So obviously t is not equal to your output, net output, so which means you have to adjust the weight again, so which means you have to calculate the change in weights, which is delta w1 equal to alpha t x1 delta w2 equal to alpha t x2 delta w3 equal to alpha t x3, and delta w4, that's equal to alpha t x4. So this should be equal to -1, should be equal to 1, and that should be equal to -1. This should be equal to -1, and again the new bias is alpha t. This is 1 multiplied by 1 again, that should be equal to 1. And now it's time to update the weights. So update weights and bias. So let's W1 should be equal to the new weight plus the old weight, which is 1. And then W2 equal to new weight plus the old weight, that's equal to 1 plus -1 plus 1 equal to 0. This one will be equal to 2. W3, the new weight is delta W is -1 plus the old weight is equal to 1. That makes it 0. W4 -1 plus the old, it's plus -1, so that makes it this is +1 plus -1, that's equal to 0. And then B is equal to the old bias is equal to 1 and the new bias is equal to 1. That makes 1 plus 1, that's equal to 2. So you have new weights, which is here, and then you have new bias. So we have to take the next set of inputs for the sample number 3 and then use these weights as the weights, the calculated weights, and then the bias value of 2. So let's do the next one. So the next step is we have to take the corresponding inputs for the sample number 3, which is x1, x2, x3, x4, and the corresponding target value. So what's that value? Let's check. What are the values? For sample 3, it's 1, 1, 1, -1, and then -1. So let's draw the perceptron again. It's a time-consuming job, but worth learning. x1 is equal to 1, x2 equal to 1, x3 equal to 1, x4 equal to -1. And then let's calculate the weights. So we have to use the weights from the previous step. So which is here 0, 2, 0, 0. So W1 should be equal to 0, W2 should be equal to 2, W3 should be equal to 0, and then W4 that should be equal to 0, and then the bias which we calculated, that's equal to 2. So we have all the information which is enough to calculate the net input. So our net input will be equal to 1 multiplied by 0 plus 1 multiplied by 2 plus 1 multiplied by 0 plus -1 multiplied by 0. Plus your bias value of 2, so that should give some value 0 plus 2 plus 0 plus 0 plus 2, that makes 4. So this will be fed to the box that containing the propagation function, which is a function of I. So this is greater than 0, so which means it will fire an output equal to 1, and then t is equal to, and we know that target is equal to -1. So clearly your target is not equal to your output, net output. So what we need to do is we have to change the weights. To change the weight, we have to calculate the change in weight first. So let's calculate W1 equal to alpha t x1. That should be equal to -1 if you calculate it correctly. Alpha, remember, it's equal to 1. T, that comes from target, that's equal to -1. And then x1, that's equal to +1. So if you multiply all, that should be equal to minus 1. So delta W2, calculate similar way, alpha t and x2, that should be equal to minus 1. If you calculate correctly, W3 will be equal to alpha t x3, that should be equal to 1 multiplied by minus 1 multiplied by 1, that should be equal to minus 1. Delta W4 should be equal to 1, and B is again alpha multiplied by T, that's 1 multiplied by T is minus 1, that should be equal to minus 1. So we have change in weight and bias, so we can calculate the weight. So you have to update the weight, so it should be the change in weight plus your old weight. So the change in weight for W1 is equal, the new weight for W1 is equal to minus 1 plus your old weight 0, W2 minus 1 plus your old weight 2, W3 minus 1 plus your old weight 0, W4 minus 1, plus 1 plus your old weight 0, and B is minus 1 plus your old bias, that's equal to 2. So if you calculate, this should be equal to minus 1, 1, W3 should be equal to minus 1, W4 should be equal to 1, bias should be equal to 1. So that's a new weight and bias. So you have to take the next input and then solve the perceptron using the weight and bias that you calculated right now. So let's take the one sample 4. For sample 4, so if you go back to the main problem, so you have sample 4 here. Just follow the green line now. So sample 4 is here. So we have the 4 inputs. We have to take this input and use the new weights and the new bias. And then let's check whether it's going to predict the corresponding target minus 1. So let's solve the perceptron again. Same story. Starts with the summation box. You have x1, that should be equal to 1. x2 equal to minus 1. x3 equal to minus 1. x4 equal to 1, and then we already calculated the weight in the previous step. So W1 is equal to minus 1, W2 is equal to plus 1, W3 is equal to minus 1, and then W4 is equal to plus 1, and then you have a bias which is equal to 1. So if you calculate the net input, that value should be equal to, so you start with minus 1, 1, 1, 1. So you will get a value of 1, and then which means your output should be equal to 1, and your target value, that should be equal to 1. So what we have here, your I value is greater than 0, which means that's why it's firing an output value of 1, but your target is minus 1. So clearly your target is not equal to your net output. We use the symbol O, so which means we have to calculate the change in weight for W1, W2, W3, W4, and then your new bias using the same formula alpha t, and for delta W1 is alpha t multiplied by x1. This is 1 multiplied by t is minus 1 multiplied by x1 equal to 1, that makes it minus 1. Similarly for W2 you get a value of 1, delta W3 you get a value of 1 again, delta W4 you get a value of minus 1. So now you can update the weights and bias for the next step. So the new weight will be equal to delta W plus the old weight, which is -1. That makes it -2. W2 will be equal to change in weight, which is +1, plus old weight, that's equal to 1. That makes it 2. W3, that's equal to delta W3 is 1, plus our old weight is -1. That makes it 0. W4 is, we have a delta W is -1, plus the old W4, that value is equal to 1. That again makes it 0. Bias alpha t is 1 multiplied by -1. That makes it -t. So the new bias is -1, sorry. New bias is -1 plus old one is +1. That makes it 0. So we have a set of weight and then the bias. So we have to go for the next iteration until we have to run the iteration continuously until we get what we should get. So we should read all the x1, x2, x3, x4. The perceptron should read all the inputs in all the 4 samples, and then it should accurately predict the corresponding target. So until we achieve this point, we have to adjust our weight and bias continuously. So that's the goal. So what we did now is we adjusted the weight and bias continuously for all the 4 samples. So the input that corresponds to all the 4 samples. So if you go back to our original data or the main problem, you have 4 inputs. Sorry, four inputs and then 4 samples. So we already solved the weight and bias for all the 4 samples. So that completes our iteration number 1. So in the language of machine learning, it completes the epoch number 1. So now we need to run the second iteration using this weight that we calculated for the sample 4, and then the bias, corresponding bias. So now we have to start with the iteration number 2. So let's do that. So let's call epoch number 2 or the iteration 2. So this is the beginning of the iteration 2. So iteration 2 will get completed once you manage to get the weight and bias of all the 4 samples. For all the 4 samples. So let's do this. You have a summation box, and then again you start with your sample number 1. This is iteration 2, sample 1. Sample number 1. So x1 equal to 1, x2 equal to 1, x3 equal to 1, x4 equal to 1. And then just now we calculated. So all this 1, this comes from our actual problem. We go back to our main problem. So that's the first sample number, which is here. So we are doing the calculation again, taking the same data. And we already calculated the weight and bias from the previous one, from the previous iteration. So let's do. W1 is equal to 2, W2 is equal to 2, W3 equal to 0, W4 equal to 0, and then the bias, updated bias, that's equal to 0. If you calculate correctly, the net input will be equal to +1, so that's greater than 0. So which means your output will be equal to 1. However, your target value for the first sample, that's equal to -1. So clearly target is not equal to output. So which means you have to calculate delta 1, delta W2, delta W3, W4, and then you have to calculate the new bias. So you have to use the same formula, alpha t x1, that should give -1, this should give +1, this should give +1, this should be equal to -1, bias is equal to -1. Just apply the same formula. So bias is equal to alpha t delta wi, that should be equal to alpha t and xi. Yeah. So now you adjust the new weight. Our old weight is the change in weight is equal to -1. That's something we calculated. So calculate the new weights, W1. So this is the change in weight which we calculated just now, plus the old weight which is 2. And then do the same for W2. That should be, I think we are doing okay, I think. So you have W1. Let's check this. Now W1 is -2 here. -2. Okay, so this should be, and this is -2 plus 2, 0, 0, all okay. And then delta W1, that's -1 plus 1, 1, -1. W2, 0, 0. This value should be equal to 0. T is not equal to 1. 1 multiplied by 1. This should be equal to +1. Delta W2 all +1. Delta W4 is +1. B is equal to +1. Yeah, I did some mistake here. So this should be the correct value. So alpha T1 is 1 multiplied by because this target value is equal to 1, not -1. So 1 multiplied by 1 multiplied by 1, that makes 1. So delta W2 is equal to 1 multiplied by T is 1 plus multiplied by 1, that makes it 1. So again it makes all 1 multiplied by 1, 1 multiplied by 1 multiplied by 1, and this is again 1 multiplied by 1, that makes it 1. So W1, that should be the change in weight. We have it here. So the new weight should be W1 equal to 1 minus 2, that makes it -1. W2 should be equal to 1 plus the old weight is 2, that makes it 3. W3 is equal to, just now we calculated the delta W, which is equal to 1, delta W3 plus old weight is equal to 0, that makes it 1. And W4, the change in weight is equal to 1 plus the old weight is equal to 0, that makes it 1. And the new bias is equal to 1 plus the old bias value, which is equal to 0, that makes it 1 again. So now you have a set of new weight and a bias value here. So we use this one to go to the next step. So we are going to use these weights and then this bias value of 1, and then we are going to read the corresponding input x1, x2, x3, x4 that corresponds to sample number 2. So this is iteration 2, sample number 1. So let's go to sample number 2, iteration 2, iteration 2 or epoch 2. So let's do the summation box again. It's a long problem, but okay. x1 is equal to -1, x2 is equal to 1, x3 equal to -1, and x4 equal to -1, and w1 is equal to -1, w2 equal to 3. Just now we calculated the new weights, and w3 is equal to 1, w4 is equal to 1, and then we also calculated the new bias. This is the updated bias, which is equal to 1. The net output I, this should be -1 multiplied by -1 plus 3 multiplied by 1 plus 1 multiplied by -1 plus 1 multiplied by -1, that plus you add the value of bias, so that makes value of 3. This is greater than 0, which means your propagation function is going to fire an output equal to 1, and your target value is already equal to 1, so which means t is equal to your objective function. So in that case, you don't have to the change in weights and the bias, that should be equal to 0, because we don't have to change the weight and bias. So delta 1 will, w1 should be 0, delta w2 equal to 0, delta w3 should be equal to 0, delta w4 should be equal to 0, and bias should be equal to 0. So what it means is, if you calculate if you want to update the weight, so which is delta w, that's equal to 0, plus old weight is 1. Yeah, so there is practically no change in the weight. So old weight is old weight is -1, so -1, that should be -1, and w2 will be equal to 3, w3 will be equal to 0 plus old weight, that's equal to 1, w4 is equal to delta w4 is 0 plus old weight 1, that makes it 1, and bias, the change in bias is equal to 0 plus the old bias is equal to 1, that makes it 1. So you have new weights and then bias, updated weights and bias. So we use this weight and bias, and then we are going to read the input in the sample number 3. So sample number 3, iteration 2. So how it works, again, I'll begin with the summation box, and then you have x1 equal to 1, x2 equal to 1, x3 equal to 1, x4 equal to -1, and then w1 equal to -1, w2 equal to 3, w3 equal to 1, w4, this is something we calculated now, equal to 1 again, and then the updated bias, that's equal to 1 again. So if you calculate the net input, this should give a value of 3 if you do it correctly, which is again greater than 0, which means it's going to fire an output equal to 1. That's how we set the propagation function. But our target value is equal to -1, and now your target is not equal to your output, which means we have to change again our weight, which means we have to calculate the change in weight using the same formula, alpha t xi. So this makes -1, delta w2 will be equal to -1, calculate it, delta w3 will be -1, delta w4 will be equal to 1, b will be equal to alpha t, that should be equal to -1. And now it's time to update the weights. So update the weights and then the bias. It's a lot of calculations. So weight 1 will be equal to -1 plus the old weight -1, that makes it -2. W2 is equal to, the change in weight is -1 plus old weight is equal to 3, that makes it 2. and W3 is minus 1 plus old weight is equal to 1, that makes it 0. W4, the change in weight is 1 plus the old weight is 1, that makes it 2, and then the bias is minus 1 plus the old bias is equal to 1, that makes it 0. So we have some weight and bias, updated weight and bias. We use these weights and bias, and then we are going to read the input for that corresponds to sample number 4. So let's go to sample number 4. Very time consuming calculation. And then iteration 2, sample number 4. So let's build the network again. What we are trying to do is we are solving the perceptron using pen and paper. So x1 is 1, w1 is minus 2, x2 equal to minus 1, w2 is equal to 2, w3 equal to 0, x3 equal to 1 minus 1, x4 is equal to 1, w4 is equal to 2, and then the updated bias, which is already we know it's equal to 0. If you calculated the net input, this should give a value of minus 3, which is typically less than 0. So which means your propagation function will fire an output minus 1, and our target in fact is minus 1. So which means in this case we don't have to change the weight. So change in weight 1, change in weight w2 equal to w3 equal to w4, that will be equal to 0, and then we will not change anything in the bias, so the change in bias will be equal to 0, and then we have to adjust the weight and bias for the next iteration. So the updated weights, and then the bias w1 will be equal to 0 minus 2, that will be equal to minus 2, w2 will be equal to 0 plus 2, that's equal to 2, and w3 is equal to 0 plus 0, that will be equal to 0, w4 will be equal to 0 plus 2, that will be equal to 2, and finally the bias, old bias is 0, new change in bias is equal to 0, that makes it 0. So you have set of new weights and bias. So we are going to use this for the next epoch. If you see this, we already completed sample 4, and then but during iteration 2 sometimes we experience that for some cases target is equal to output, which is good, but for some inputs that corresponds to some of the samples, your target was not equal to output, so this is not good. So we have to find the weight and bias so that for all the samples, all the 4 samples, we should read the corresponding input, and then it should successfully predict the corresponding target value. So let's use these new weights and then the newly calculated bias, which is here, and then let's start the iteration number 4 or iteration number 3 or epoch number 3 or epochs, I don't know how to pronounce. So let's solve this huge problem. So you have x1 equal to 1, x2 equal to 1, x3 equal to 1, x4 equal to 1, and then we know the corresponding weight minus 2, 2, 0, and 2, and then we have the bias, which is equal to 0, or the updated bias, and these are the updated weights. So from there we can get the net input. If you calculate correctly, you will get a value I is equal to 2. We already calculated that value, which means it's going to fire an output which is equal to 1, because I is equal to 2, 2 is greater than 1, and our propagation function is going to fire an output 1. If you compare it with your target value, which is already 1, so this is a good news, because target is equal to output, so change in weights will be equal to 0 and the change in bias will be equal to 0. So your new weights and bias, or your updated weights and bias will remain the same, which means W1 will be equal to -2, W2 will be equal to 2, W3 will be equal to 0, W4 will be equal to 2, and then the bias will be equal to 0. So we are going to use this weight and bias, and then we are going to read the input that corresponds to sample 2. So let's do that. So sample 2, and then the iteration epoch 3, so the summation box, draw the summation box. So x1 is equal to -1, x2 equal to +1, x3 equal to -1, x4 equal to -1. So feed all of them. New. So we'll add the weights in red color, -2, 2, 0, 2, and then you get a net output, net input using the same formula, wi xi, take the sum plus add the bias. So if you do it correctly, you get a value of 2. 2 is greater than 0, which means your propagation function fi will fire an output equal to 1, and your target value is actually equal to 1. So in this case, what it means, target is equal to output, so which means change in weights that should be equal to 0, so which means your updated weights will remain the same. Your updated weights will be equal to the weights that you calculated in the previous step. Updated weights and bias. So W1 will be equal to -2, W2 will be equal to +2, W3 will be equal to 0, W4 will be equal to 2, and obviously the bias will remain the same. I forgot to add bias here. Bias is equal to 0, and your bias will be equal to 0. So far, when we are running epoch 3, for all the weights and bias, we observe there is no change in weight and bias, and it successfully predicts the output for the corresponding input in the first 2 samples. So let's use the same weight and bias, and then let's try to solve the third sample, which is sample 3. So let's use the same rule. We have 4 inputs, obviously. So what are these inputs? So sample 3, x1 should be equal to 1, x2 should be equal to 1, x3 should be equal to 1, x4 should be equal to -1. So let me write down weights. Weights are given by -2 for x1, +2 for w2, that's w2, w3 is equal to 0, w4 equal to 2. So w1, w2, w3, w4, and the bias, which is equal to 0. That's updated bias. So if you calculate the net input, which is I is equal to summation of wi xi plus b, let me calculate one time, -2 multiplied by 1 plus 2 into 1 plus 0 into 1 plus 2 into -1 plus 0, that makes it -2. So which is what? Which is less than 0, which means your propagation function f of I, according to the rules that we set, it will fire an output that's equal to -1. And indeed, this matches with your target. Target for the third sample for the given input is equal to -1. Just go and read the question again. So which means t is equal to your output again. This is for sample number 3 now, which means the change in weight should be equal to 0. So in that case, your weights and bias will remain same. So your weight 1 will be equal to -2, weight 2 will be equal to 2, W3 will be equal to 0, W4 will be equal to -1, and then your bias will be equal to 0. So practically no change in weight so far for the last 3 steps, and currently we are in epoch number 3, which is iteration number 3. So now we have only one more sample to check. So let's check the sample 4. So we have sample 4, and then let's apply the rules that we know: x1, x2, x3, x4. x1 is equal to 1, x2 equal to -1, x3 equal to -1, and x4 equal to +1. And then let's add the weights there. So your weights are -2, 2, 0, 2, and then you have a bias which is obviously 0, and then you calculate the net input, summation of wi xi plus b. You have an output. So if you calculate correctly, this value will be equal to -2. So you have to multiply, say 1 into -2 plus -1 multiplied by 2 plus -1 multiplied by 0 plus 1 multiplied by 2 plus 0. That should get -2. And this should give an answer. So this is typically less than 0. So your propagation function should fire an output of -1. And in fact, our target is also equal to -1. So which means the change in weight will be equal to 0. So W1 will be, change in W1 to W4 all should be equal to 0, and change in bias will be equal to 0. So which means your updated weights and bias will remain the same. So W1 will be again equal to -2, W2 will be equal to 2, W3 will be equal to 0, and W4 will be equal to 2, and bias will be equal to 0. So that solves our perceptron. So why I say it solves our perceptron? Because for the last 4 steps, which means epoch 3, and we read all the inputs, we have only 4 inputs: x1, x2, x3, x4. That corresponds to all the samples, which is 1, 2, 3, and 4. And then it successfully predicted the corresponding targets with 100% accuracy. So which means the perceptron is solved, which means, so these are the final weights. So let's write the solved perceptron, how it looks like. So to solve the given problem, the perceptron will look like this. x1, x2, x3, x4, and the correct weights are -2, W2 equal to 2, W3 equal to 0, W4 equal to 2, bias that's equal to 0. So that's the perceptron. I is a function of f. That's our propagation function box, and we know the rules already. That should give an output. So that's the solved perceptron. And then if you read the problem again, I said to you that let me go to the question again. sure where I kept the paper. So we have to validate. So we already know how to solve the problem. Now we need to validate. So if we go back to our question, so test the perceptron. So read this line. So follow the highlighter. So read this line. We have to test the perceptron for its accuracy for the given input. So this is a new input. Let's call validation data set, and then check whether the solved perceptron can predict the corresponding target, which is here. So it should read these inputs and then it should predict the output. So which means these weights and bias are really of good quality here. So let's go and test it. So that's the solved perceptron that we found. And then, so we use this weight and bias. So the x1 from the testing data set, that's equal to -1. x2 from the testing data set equal to +1. x3 from the testing data set equal to -1. x4 from the testing data set equal to +1. And then we know the corresponding weights. So let me write it in the purple. The weights are -2, +2, 0, 2, and then the bias is equal to 0. And then if you calculate the net input, so if you calculate the net input for this one, what we have here, so it should be -2 multiplied by -1 plus 2 multiplied by 1 plus 0 multiplied by -1 plus 2 multiplied by 1 plus your bias value of 0. That should give some value of I think I'm getting a value of 6, which is greater than 0, which means your propagation function should fire an output equal to 1, and that matches with your target, which is equal to 1. Target, that should be equal to 1. Okay, so this works. So try to calculate the net input correctly. So you should get a net input value of 6. This should be equal to 0. So which means the network with the calculated weights which range from W1 to W4, and the bias, it predicts the target values for the given inputs in the actual data set, which we can call it as a training data set, and the ones for the given input in the testing data set. So both should be okay. So which means this perceptron is solved, and the corresponding weight and bias that we calculated, we can consider that as the final value. And that's all for now. Maybe I will quickly summarize how the neural network works. So actually we know once you solve this problem, you know how the single perceptron works, and then so that's the simplest neural network that you can construct. But if you want to increase the sophistication, you can add 1 neuron, 2 neurons, 3 neurons, and then you can have any number of inputs. So any number of inputs. Say we have 3 inputs, 1, 2 and 3. So we get something like that. Yeah. So this makes one layer, and if you want we can build one more layer that contains 2 neurons. In that case, the output from each neuron in the previous layer will act as an input to the neurons in the next layer, something like this. So that's how it works. And if you want to calculate the number of weights and bias, that's really simple. So if you have 3 inputs and if you have 3 neurons, so each input will be fed to each of the neuron in the first layer. So which means if we have 3 inputs and 3, which means from each input we will feed that information to each of the neurons in the first layer. So which means the total weight will be equal to the number of nodes in the nth layer multiplied by the number of nodes in the nth minus 1th layer, and then the number of bias will be equal to number of neurons in each layer. So that's how it works. So if we have one more layer here, 2, let's say that second layer contains 2 neurons. So what we have, so in the first hidden layer you have 3 neurons. So you will get input from each of the neuron in the first layer to each of the neurons in the second layer. So if your first layer contains 3 neurons and the second layer, hidden layer, contains 2 neurons, the total weights will be equal to 3 multiplied by 2, that will be equal to 6, and then the weight connecting the number of bias involved in the second layer will be equal to number of neurons, that will be equal to 2. So that should be enough for the moment. And then if you want to build so there is no rule for the architecture, so you can build any type of architecture. So if it's 10, 10, 1, this means your first hidden layer contains 10 neurons, second hidden layer contains 10 neurons, output layer, this is the last one, is by default is an output layer and typically it's 1, so that contains only one neuron, and then anything that precedes the first hidden layer, that should be equal to your inputs, number of inputs.